Hi everyone, welcome back to the week one of MLOps basic series. Here in this particular series, we are discussing about the blogs from Raviraja Ganta. In the first week, we discuss the week zero that we have. We discuss about the MLOps basics that we have. In this particular session, we will be discussing about the model monitoring, and this model monitoring we will be discussing from the weights and biases. And particularly before beginning this particular session, there's one question: why model monitoring? What's the reason why we should monitor the model? So one of the things is model monitoring can help us understand how the model is doing, the accuracy of our predictions, helping us to prevent errors and tweak our model, iterate our model to perfect them. So a lot of times when we are doing ML engineering, we do not know what's the exact right answer is. However, to get to that exact answer, we do tweak hyperparameters, try out different models, try out different tests, vary the different metrics that we want to measure those things on, and change a little bit data and do all sorts of experiments. And having all these things, the results, the accuracies logged at a particular place will help us in getting better and faster insights. And for that particular reason, we do the model monitoring. And there are a lot of model monitoring libraries available in the current days, such as Comet, MLflow, Neptune, TensorBoard, weights and biases. So if you have been following us in this particular series, in the last session, we discussed about the TensorBoard, which is inbuilt, I think, by for TensorFlow, then it was extended for PyTorch and PyTorch Lightning. In this particular session, we'll be discussing about the weights and biases. And in this particular session, we'll discuss about a couple of things like how do we configure basic logging with weights and biases, then how do we compute metrics, and in case if we have enough time left, we'll also discuss how we can add plots in weights and biases, and then how to add data samples. And basic knowledge of machine learning, PyTorch Lightning is needed for this particular session. And if you haven't been through the last two sessions that we had in the series, I recommend you to please go back and then continue watching this thing from there. Weights and biases configuration. So once you log in, once you made up an ID on weights and biases, you can in the command line or whatever Jupyter notebook or Colab notebook that you have, run this particular command warndb login, and then it will ask you to go in that particular website and then enter some API key. And then I understand like each one of us is smart enough to understand how we initialize this thing using the initialize and logging using the API key. So I'm just moving forward. Next is configuring. It's like creating a project on weights and biases. This particularly, first we import the loggers of weights and biases from PyTorch Lightning, and then we create an object. We create a object of warndb logger. In here, all the logs will be going to the MLOps basics project folder. And then we have just created this particular warndb logger. Now for using it's pretty easy. What we are going to do in the trainer that we have, we were earlier using for orchestrating the training part of the model. We were using trainer there, and in this that particularly we were using the logs in some another way. Earlier we were using the TensorBoard one. Now here we are just passing on the warndb weights and biases loggers. So now all the logs will be tracked by the weights and biases. It's just so easy to start with. However, moving on, like how do we use metrics in this particularly? So for metrics, we'll be using the torch metrics, which we can use this thing in PyTorch Lightning also. If you want to check the documentation, you can go on these links. And in this, generally here we will see how we can calculate the accuracy, precision, recall, and F1 score. So first, like everything, we import the torch metrics, and then in the model class that we were creating, we will make some changes to the initialization that we have in the model. In that particularly earlier we didn't, I am not sure if you remember, but like earlier we didn't have this these exact metrics. Here we are taking the training accuracy metric from torch metrics accuracy. Similarly for a validation accuracy metric. And then we are also taking the F1 metrics from number of classes equals to number of class, and then precision macro metric, in which we are saying average, we want a macro uh, average. Similarly, for precision and recall, we are doing the same thing. And then we are saying we are also trying to find the micro for precision and recall. So, and all these metrics can be calculated similar in a similar sense for all the three steps in the first training part, validation part, and the testing part. Here above, we have mentioned for the training and the validation part. You can do the similar thing for the testing part. Out of these three, we'll be focusing on the first two, the training and the validation part. So in this particularly for the training step, this is where batch of training data is processed, and we will put like training loss, training accuracy here. In validation step, we'll process like the validation loss and validation accuracy. And then there is training epoch and validation epoch, and this is like this thing is called at the end of every epoch. All the data will be returned by all the data which is returned by training step can be aggregated here. And test step when we have trainer.test, but generally we are not focusing on this thing for the time being. And then for logging, there are certain configurations available, such as progress bar, which will enable like to show metrics on the progress bar. Then epoch equals to true, that in that particularly when an epoch gets concluded, all the metrics that we have will be aggregated and averaged across the batches in that particular epoch. And then on step equals to true, the metrics will be logged for each batch, which is generally useful and non-useful depending on the case that we have. If you have lost, then it's useful. So in training, the on step is by default true, and in validation, like the on step is false. However, on epoch is true. For further documentation, you can refer to this link. The next we have like how metrics calculation logging looks like in the training step. Here we were uh, first passing the forward layer, in which we are passing the input IDs, attention marks, and the labels, and then we get the output. From output, we are taking the maximum argument to get the predictions. Now to get the training accuracy metric, we are passing the predictions and the labels. And now we are earlier, if you remember, we are not doing all these things, but here we are logging the train loss and train accuracy. So if you can see, I'll try to zoom in. So on each epoch equals to true is enabled in weights and biases. In training or loss step, uh, we'll get this graph, and we'll also get the loss epoch thing. Similarly for accuracy and the training and the step and the epoch, we got these graphs. While we are doing the validation step, we would like to we generally want to monitor metrics like precision, recalls, and F1. So we'll be using those particular thing here. So I think these are almost same as what we had for the training step. And now for the validation accuracy, recall, these are almost the same. So I think we didn't had the F1 metric above calculating we were not calculating the F1 metric here in this particular step. So here we are calculating the F1 metrics and then logging everything like validation, precision, recall. And however, we are only running for one epoch. That's the reason why you are only seeing only one data point here. And the values returned during the validation step can be aggregated in the validation epoch end, and that's what you see here. These are for particular epochs. And for the labels and logics, you can create a confusion matrix. That's what they have done. So I think for this session, this is enough, and we'll be discussing the other details in the next session. Thank you for joining this session.